Is the screen visible now?
Yes, sir.
Okay.
Yes, sir.
So, people have been intrigued by the planets. They have been trying to find ways and means of studying the planets, calculations, distances, why there is night, why there is day, why seasons change, why sometimes the day is longer, sometimes the day is shorter, why in different latitudes, sometimes there is always night, sometimes there's always day. So people have been studying, over centuries. And then they came upon so many inferences. One was that the earlier, people thought the sun is moving. And when Galileo or somebody said that the sun is stationary, they shot him also. So many things they did. So first thing they said the sun is stationary and the earth is moving around the sun. Then they also found out that the motion is not in a circle, it is elliptical. That is very easy to find out why the motion is not in a circle. If you take azimuths regularly, especially of inferior planets, think about it, and you can see, okay, the maximum azimuth on the left was so many degrees, on the right is so many degrees. Why it changed more, why it happened less. The time, maximum time between the left azimuth and the right azimuth, in one period it is less, again going from right to left it is more. Today I will do Venus as a morning evening star with you, so you will understand more. Because if a planet is going around in a circle, perfect circle, then the readings will be same on the left side, on the right side, any time of the year, the readings will be the same. But because readings are changing throughout the year, so people could easily decide that the path is not circular, it is different. So elliptical path. So the first law states that all planets revolve around the sun in elliptical orbits, with the sun situated at one of the foci. An ellipse is a locus of points as the sum of its distances from the two foci is always constant and equal to the length of the major axis. Here you can see the Earth is revolving around the sun, but the sun is not in the center. For Earth, maybe the sun is on the right foci. Maybe for some other planet, it is on the left foci, because all paths are elliptical, and all paths, all planets' paths may not be all matching with one another. They may be different, but all elliptical. So second law. Second law states that the radius vector. What is a radius vector? A line joining the center of sun to the center of planet sweeps equal areas in equal intervals of time. Maybe this diagram will explain that a little better. You see the sun is closer to the earth on the left side. And yesterday we said something which is closer, it appears to move very fast. You are moving at the same speed in a train or a car. But when you look out of the window, far away objects like the moon, sometimes at night, it remains on the window for a very long time. But the nearby trees, buildings, everything will pass off very quickly. So we say that a thing which is far off, the angular velocity is slow. Thing which is close by, the angular velocity is more. But you are moving at the same speed. Am I right or no?
Yes, sir.
Yeah. So the Earth is moving at a constant speed around the sun. The Earth does not increase its speed. But because we are coming closer to the sun or going further away, it appears the angular velocity. So let's say a duration of 1 month. In perihelion, the angular velocity will be more. That is when the sun is close. it will appear that the Earth has covered a more distance, and it has, no problem. And for the far object at aphelion, it will appear that the Earth has covered less distance. Okay, that distance may be more or less, but Kepler says that the area is the same. So the area A1 is equal to area A2. Is this point clear, gentlemen? Any questions over here? The sweep is more. This diagram seems to be a little better. So here I am sure you will be able to understand. Who had that question? Is it clear for you?
Yes, sir.
So the inference is that the angular velocity increases. Read the para down below. The planet has to move at larger angular velocity when it is at perihelion than it is at aphelion. Third law. We saw in that table yesterday, the closer planets like Mercury, Venus, Earth had a smaller period of revolution around the Sun. Earth is having 365 days. But the further you go, the bigger the circle. Let me show you a slide over here. So it's quite natural because Jupiter, Saturn, Uranus have to make a bigger circle, so their period of revolution will be longer. Is there any doubt on this? Anyone? So a direct relationship exists between the distance from the Sun and the time it takes to make one revolution. Any doubt on this statement that I have made? Anyone?
No, sir.
Okay. Now, what is that relationship? That relationship is t square is directly proportional to a cube, or t square upon a cube is a constant. T is the time taken and a is the distance from the Sun. This is a constant for all the planets. So just do this small calculation. I don't know why you did not do yesterday. Do this small calculation and we'll see. Earth is 365 and a quarter, no? So 365 and a quarter square divided by distance cube. Can we do this? You all have calculators with you?
Yes, sir.
Or no?
Yes, sir.
करो फटाफट जरा देखें.
Yes, sir.
See what answer you get. In this slide, they have made it a little simpler. They have made the distance into astronomical unit. But you can do the other way also. Otherwise, first you'll have to reduce it to the astronomical unit. Anyone got the answer? You should be able to do it by now, scientific calculators. Nobody with the answer as yet? Shall we leave it as a homework once again? I'm sure you
Yes,
can do
sir.
better than this.
Yes,
Huh?
sir. We are doing, sir. We are doing, sir.
Don't get confused with those too many zeros, huh? That you can add later on also. I'll give you another half a minute or 1 minute. If you get the answer, okay, otherwise we move on.
Sir, 1.65 is 10 to the power minus 19 for Earth.
Very good. For any other planet? Do it for Venus or Mars, whatever, whichever you
Sir,
find convenient.
for everyone, it will be constant, huh?
Yeah, it has to come same answer. That is the Kepler's law. We know if the distance is more, if the radius is more, the circumference will be more and the time taken will be more. But what is that relationship? That relationship is t square upon d cube. Okay. So I'm sure you will get the
Yes, sir.
answer. If you want, just quickly check for another planet and then we'll move on.
Yes, sir. For Mercury, it is 1.659 into 10 to the power minus.
Yeah, it is same, almost same, you can say. Maybe a little accurately, if you do, you'll get the correct answer. So everyone understood this one now? Any doubt again on second and third law?
No, sir.
Yeah. Go through the book again, read once more. Still, if you have any doubt, we can always discuss in class. So, okay, I'll move on now. Today I will do with you day and night, how day is caused and night is caused, how seasons are caused, and then we'll also discuss morning and evening star for Venus. So can anyone tell me why do we have day and why do we have night?
Sir, because of the rotation of Earth.
Because of the rotation of the Earth. Very good. So what happens when the Earth rotates?
Sir, the rays that are coming from sun are directly coming slanted towards the Earth's surface. There will be the light zone, and the one which is exactly opposite to that side will be the night side.
Okay. So I will be switching on the camera and taking you to the board, and then we will see how it looks. I will leave this sharing screen also on, and then I will switch on the camera, so I think you'll be able to see both. You can toggle between the two. Just let me know the setting when the board is clear. Is the board clear now, visible to you?
Yes,
Yes,
sir.
sir.
Is it clear and sharp?
Yes, sir. A little bit blurred.
Little blurred.
Yes, sir. Good. No, it's good, sir.
Chalega?
Yes, sir. Chalega.
Okay. So the sun is in the center, the red one. The path is in black, the revolution path, and this is the Earth. Correct. So the portion which is facing the sun rays are coming like this. The portion which is facing the sun will have day, and the portion which is away from the sun will have night. So is this what we are trying to say? So this part is dark, nighttime, people are sleeping.
Right, sir.
And this other part, the green ink is little light, I will try to fill it up. This is daylight, daytime. And in which direction is the Earth rotating? West to east.
West is.
west to east. That is how the Earth is rotating. So, simply if I ask you a question, what is the time for an observer at this point? Just a very layman simple, don't think too much about it.
Sir, morning time.
Morning 6 o'clock, I can say.
Yes, sir. Yes, sir.
Morning 6 o'clock. Because sun is just, the Earth is rotating like this. It is nighttime, is sleeping. When it comes in line like this, the first ray of the sun hits him over here, the sunrise. And what is the time over here?
Afternoon time, sir.
12 o'clock. Sun is crossing the meridian. So an observer who's sleeping over here, when the Earth is rotating, sunrise, and at this point, when he comes, the sun is right over his head. The sun is crossing his meridian, it is 12 o'clock. And over here again, it is 6 o'clock in the evening.
Evening.
Sunset, and it becomes dark, night time. So this is how the day and night is caused. In between, there will be some gray area over here, which we will study separately. Maybe tomorrow. In between, there will be some gray area over here. What is this gray area called? Twilight. Bhor and Sanj. Twilight. Because it will suddenly, it's not like a bulb, you know, that you put a switch on and it becomes, you can see the sun. And again, when you put a switch off, the sun will disappear. You know, first there is daybreak, there is slight brightness coming, and then you see the sun, am I right? Yes or no?
Yes, sir.
Evening also, when the sun sets, when the upper limb of the sun disappears beyond the horizon, there is still brightness and it takes a little time to get dark. Am I right?
Yes, sir.
So there is some area which is called twilight. And neither day nor night, somewhere in between. The definition of twilight and officially what it is, we will discuss when we discuss twilight. At what time exactly it starts and what time it ends. The timings are given in the nautical almanac. We have to find that out also. So this is how day and nights are caused by the rotation of the Earth going from west to east. So if the Earth is going from west to east, which side the sun appears to rise from? East or west?
East. East, sir, east.
Yeah, because if this is west and this is east, the Earth is rotating like this. So if you look in the east direction, you will see the sun rising.
सर ब्लर हो रहा है सर.
Screen blurred है?
Yes sir. सर एक बारी वो शेयरिंग ऑफ कर दीजिए ना सर, तो स्क्रीन अच्छा है.
क्या कर दें ऑफ?
सर वो जो शेयरिंग है सर.
जोर से बोलो, I couldn't hear you.
सर स्क्रीन शेयरिंग ऑफ कर दिए, बोर्ड क्लियर आ गया.
अच्छा, स्क्रीन शेयरिंग ऑफ कर दें. वो तो you can toggle between the two, no? या कोई प्रॉब्लम है उसमें?
एक्सक्यूज मी सर.
या
सर प्रॉब्लम से ये आती है सर रिकॉर्डिंग में सर, उस आपकी ये है ना ब्लैक बोर्ड, ये दिखता नहीं है सर रिकॉर्डिंग में. अगर देखना चाहें तो सब स्क्रीन आती है, फिर रिकॉर्डिंग में फिर टॉगल कर नहीं पाते हैं.
So you must be facing this problem with others also or no?
नो सर. सर ये क्या बात है, वो एक
अच्छा,
बार में
you
एक ही
want-
चीज कराते
You
हैं.
want to save the screen, you want to save the recording basically.
यस
तो आप
सर,
तो किस पे ज्यादा ध्यान दे रहे हो, क्लास में या रिकॉर्डिंग में?
दोनों पे सर।
अगर क्लास पे ध्यान दोगे तो
सर
रिकॉर्डिंग
दोनों
की
पे
जरूरत ही
सर।
नहीं पड़ेगी तुमको देखने की,
यस सर।
बिकॉज
सर वो बाद में कभी रिवीजन के लिए काम आ जाता है
हाँ
सर।
समझ गया, ठीक है। मैं ये नहीं कह रहा कि मत देखो या मत करो। द पॉइंट विच आई एम ट्राइंग टू से इज, इस समय जो तुम्हारा फोकस क्लास में होगा ना, जो एकदम टोटल फोकस, यू आर नॉट थिंकिंग ऑफ एनी अदर सब्जेक्ट और टॉपिक, ये टाइम दोबारा, ये वाला परफेक्ट एग्जैक्ट टाइम जो है, ये तुमको दोबारा नहीं मिलेगा। तो जितना मैक्सिमम इस पे कर सकते हो करो, बाकी बुक एंड रिकॉर्डिंग यू कैन क्लैरिफाई योर डाउट्स लेटर ऑन ऑल्सो। सो माय क्वेश्चन वाज, अभी ठीक है? स्क्रीन शेयरिंग बंद कर दिया मैंने।
यस
यस
सर।
सर।
ओके, इसमें कोई डाउट है? हाउ डे एंड नाइट इज कॉस्ड? सन राइजेस इन द ईस्ट, और जब सेट होगा तो तुमको किस डायरेक्शन में दिखेगा?
वेस्ट सर।
वेस्ट में सर।
वेस्ट में
वेस्ट
तुमको
में सर।
दिखेगा। हाँ, वेस्ट में दिखेगा, क्योंकि अर्थ रोटेट कर रही है और तुम्हारा डायरेक्शन चेंज हो जाएगा। सो आई विल स्लाइटली मॉडिफाई दिस diagram now. We'll come to seasons. So yesterday someone had a doubt because the earth is in an elliptical path, so when it is near the sun it is summer, when it is far from the sun it is winter, but actually it is opposite. The sun is far in the summer and sun is near during the winter. So what is it that causes the seasons? Anyone can give me an answer?
सर जैसे जैसे सन से दूर जाते हैं वैसे वैसे winter
Revolution of Earth.
Pardon?
Revolution of Earth causes the season.
Revolution of the earth causes season. Revolution तो होता ही है, उसमें कोई डाउट नहीं है।
So tiltness
सर
of
जब
the
सन से दूर जाएंगे एंड जब सन के पास आएंगे, जब सन के पास आ जाएंगे तो सर गर्मी हो जाएगी, जब सन से दूर जाएंगे तो ठंड हो जाएगी।
मैं वही तो कल कह रहा था, वो गलत है। That is not
नहीं सर, ये
correct.
तो नहीं है।
tiltness of the earth on its own axis.
The tilt of the earth, the tilt of the earth causes the seasons. Very good. And what is the angle of tilt we said yesterday?
23 degrees, 23 and a half degrees.
3.5 degrees.
23.5.
So the earth which is rotating on its axis is tilted by 23.5 degrees. So I will just modify the diagram slightly. Okay. So 23.5 degrees is like this. Everyone can see what I'm drawing on the board?
यस सर।
Yes, sir.
Okay.
Yes, sir.
So which is the geographical North Pole? This point over here straight, or the axis where it cuts the axis? Which is the geographical North Pole and the South Pole? The very first page in that principles book, it is written, the earth spins on its axis, and where the axis cuts the earth's surface, those are the geographical poles, North Pole and South Pole. So don't make this mistake, gentlemen. This is the North Pole where this red line is cutting the earth's surface, and this is the South Pole. Is it clear? Yes or no?
Yes, sir.
These are the geographical North Pole and South.
Yeah. Now, why is the Earth pointing in the same direction in space? Mark my words. The Earth is pointing in the same direction in space. Yesterday I said there is no left, right, east, west. Everything is made by us. We have given conventions, we have given reference points, names for our convenience. But if you look at this, during the entire year when the Earth is rotating every day, so she's taking 365 days to make this big journey. So every day she's moving about 1 degree, 365 days in a year. And she
Yes, sir.
turns 360 degrees in 24 hours 1 day. So second day she will be here, third day she will be here, fourth day, fifth day, like this. 3 months, after 3 months she will be here. After 6 months she will be here. After 9 months she will be here, and after 12 months she will come back from where she started. During this entire process, she remains in the same pointing in the same direction. So the axis is pointing to the same direction in space, we say. Yesterday I had given you a small hint why it happens. You see, the Earth is moving very fast, I said, but she is not wobbling at all. She is not unsteady at all. Why is this axis not pointing in some other direction in this entire journey? She is not getting affected by any external force.
The gyroscopic effect.
Yeah, because of the gyroscopic inertia. Very good. Gyroscopic inertia. So what does the gyro say? What are the two properties of gyro? That a body.
Rigidity of
The first is
space.
rigidity. Second is precision.
Precision.
Very good. So which property is this one?
Rigidity of space.
Rigidity in space. Very good. The gyro remains rigid. It will not move from the direction it is pointing. The other is precession. Precession we will see in some other topic, very interesting topic later on. But here, I just want to remind you that because the Earth is a perfect example of a gyro sphere, it is a ball, perfect ball almost. It is rotating at a very high speed, and it is free to move in all the directions. It is suspended in space. It can move in azimuth, it can move in altitude, it can spin, it is already spinning. One thing is doing continuously, other two things it is not doing, but it is free to do so. It is free to, this one is free to go like this. There is nothing preventing it. And it is also free to go like this into the plane of the board and outside of the plane of the board. And the third thing, it is rotating. That is already happening. So it is a perfect example of a gyro. That is why, because of the rigidity in space, it continues to point in one direction. Now, because it continues to point in one direction, and because the axis is tilted, we have seasons. If this axis would have been straight, and the Earth would have been revolving like this, then we would not have had any change of seasons. We would not have had any change of seasons. We would all have 12 hours daylight, 12-hour darkness, and the places which are warm will always remain warm. The places which are cold will always remain cold. There will be no change of season. So by the end of this topic, you will understand why it is so. So let me start. I will start with this one over here. This is 21st March. This is 21st March. What is the declination on 21st March? Anyone?
0 degree, sir.
0 degree. And what do we call that? We call it an
Vernal
equinox.
equinox.
This is a vernal equinox. V-E-R-N-A-L, equinox, because the day and night is of equal duration. 12 hours sunrise, 12 hour sunset. Local time 6 o'clock sunrise, 6 o'clock sunset. Why this is happening? Because the Earth being inclined to its axis. I'm just wondering if some other diagram will. Okay, we'll keep it like this only. The ray of the sun is directly hitting at the equator. Ray of the sun is directly hitting at the equator, center point. Here also and here also. The sun is right overhead. 21st March. In the book you will see this portion is marked dark because it is facing us and away from the sun. So that not much of an issue. The sun travels in a easterly direction and reaches that point on 21st June. So you can see the sun is further from the earth. This one is closer, but it is summer over here. So here very interesting, we will see now why there is summer. Is it summer all over the earth at that time?
No, it's the northern hemisphere only.
No, sir.
Northern hemisphere, southern hemisphere is having winter. So what can you see from the diagram?
Sir, due to tilt of the Earth, northern hemisphere is pointing towards sun.
Yeah. So if this is my geographical North Pole and South Pole, the equator will be 90 degrees to this. The equator will be 90 degrees to this. Yes or no?
Yes, sir.
Yes, sir.
So you can see the southern hemisphere, some portion is outside here, and northern hemisphere, more portion is inside. Sun is directly hitting some point over here. What is this point? Sun is hitting directly this point.
Tropic of Cancer, sir.
Very good. 23.5 degrees north, Tropic of Cancer. Declination of the sun on that day is how much?
Or maximum 23 degree.
23.5 degree north.
Yes,
Tropic of Cancer is on 23.5 degree north. The sun is directly pointing in that. So the entire northern hemisphere is having more sun. Southern hemisphere is having less sun. So that is why it is summer in the northern hemisphere. Any questions so far?
So it will cover whole northern hemisphere.
You see now, this is turning 24 hours. The rotation is continuous. We have not stopped the rotation. The Earth is rotating like this. She is there for 24 hours. She's taken 3 months to go from here to there. So every day 1 degree she is moving. Because in 365 days, she has to cover 360 degrees. So approximately 1 degree every day. Slowly, slowly. But at the same time, she's turning also, no, once in 24 hours. So when she's here, she's turning. Even one day before also she was turning. One day after also she will turn. So which side is tilted towards the sun? Which hemisphere? Northern hemisphere. So it will always
Yes,
remain
sir.
like this. Northern hemisphere tilted towards the sun and turning. Southern hemisphere tilted away from the sun and turning. See, in celestial navigation, you have to use your imagination. The first thing which I said, if you can think in 3 dimension, use your imagination like a child. Move yourself anywhere in the universe, anywhere. Now what we are looking at our solar system or sun from outside. Are we not looking at it? So we're trying to imagine. The Earth is continuously rotating, but moving 1 degree in 1 day to complete the revolution. So even while she's there for 24 hours before she moves 1 degree ahead. Am I right or wrong? Not able to understand? I can look for a YouTube and show you, but like I said yesterday, all these things, if you go to YouTube, you'll find the 3-dimensional explanations very, very clearly. Yes or no?
Yes, sir. एक बारी दिखा दो.
Let me find if I can find one. मिल तो जाएगा. Not much of an issue. So after 21st June, again the sun is moving. This portion is called spring. S-P-R-I-N-G. Spring season from March to June. Don't think about India only. India, sometimes we have summer over here, we have monsoon there. But internationally, this is known as spring. And this is known as summer. This is autumn. And this is winter. If you have been to the northern latitudes, you will know that even in February and March, the northern latitudes are very, very cold. So after 21st June, what happens? The declination of the sun starts reducing. Yes. Have you noticed in the almanac? Yes or no?
Yes, sir.
Here, if you want, I can show you one more diagram, which might make it a little easier for you to understand. Let me see where it is. Okay, I'm sharing my screen for a minute. Just look at this diagram. Here the axis is not tilted. The Earth is upright. Can you see the screen on my computer?
Yes, sir.
So
Yes, sir.
North Pole is on top. The Earth is that small circle inside North Pole and South Pole. The equator and the equinoctial is shown. And here you can see the path of the sun, the ecliptic, which is tilted at 23.5 degrees. When we do the celestial sphere, I will explain you this one. This is the path of the sun. So where it says maximum declination of sun 23.5 degrees, right side on top, that is the date we are talking about, 21st June now. And what you saw, the first point of Iris, where the ecliptic and the equinoctial is cutting, that is the vernal equinox, 21st March. The sun is, at that time the declination was 0. The declination starts increasing. Maximum declination 23.5 comes on 21st June. After 21st diagram, can anyone tell me?
What, sir?
Sorry, sir.
After 21st June, after the maximum declination of the sun attained, 23.5 degrees,
सर आपकी वॉइस
Sir,
बहुत
your
ज्यादा
voice
ब्रेक हो
is
रही है,
it is
distorted.
going
नहीं
down.
समझ आ रहा है.
आप अटक अटक के आ रहे हो सर.
Pardon?
सर आपकी वॉइस
अब आपकी ब्रेक हो रही है.
Voice is breaking, is it?
Yes, sir. सर स्क्रीन भी हैंग हो गई है.
सर आप अटक गए सर.
How's my voice now?
सर वॉइस आ रही है पर आप अटके हुए ही हो.
Voice is better now or no? Is
Yes,
my
sir.
voice better now?
Yes, sir.
Yeah, so my question was, if you're looking at the diagram on the laptop, my screen sharing, the sun has got maximum declination 23.5 degrees on 21st June. If you see the path of the ecliptic after 21st June, what is happening?
Declination will reduce.
The sun is going down on the other side, the path of the ecliptic. The declination starts reducing, and again when it reaches that first point of Libra, the declination is again 0. So if you look over here, it is the same thing. After 21st June, the declination starts decreasing and the sun reaches here on which date is this?
सर अभी भी काफी डिस्टरबेंस है आवाज में आपके.
Achha. Actually, I tried changing the net, so sometimes maybe now, but this one looks better. Maybe it is better now. I have gone back to my broadband, so is it better now? Can you hear me, guys?
Yes, sir.
Okay, I think between my voice and between the diagram, you should be able to make out what is going on.
Yes,
So let us see now, where are we? Okay. So 23rd September, we reach this point once again. This is another equinox, which is called the autumn equinox. Autumn equinox. कितने बज गए? Tea
10
time हो गया.
o'clock, sir.
सर ब्रेक ले लो.
Okay, let's take a
Yes, sir.
break and let's hope the net also improves by then.
Okay, sir.
Have your tea, gentlemen, and then we'll meet again in 15 minutes.
Thank you, sir.
Thank you.
Thank you, sir.